Go ahead, John.
Okay. So thanks, Stephen. My name's John Ludlam, and I work for Citrix in Cambridge, in the UK. And I work on the Zappy project. So those of you who don't know what that is, it's the little control stack of XCP. So it coordinates the resources in a pool of hosts. It's responsible for the XML RPC interface, database, VM power state operations, calling storage plugins, and all sorts of other miscellaneous bits and pieces. So this is the first time that anyone from the Zappy team has come to talk to one of these things. So it's sort of came here with a bit of trepidation. So when I arrived and Stephen said, hi, you're going to get attacked by questions. So that really put me at ease. So thanks, Stephen. That's helpful. Okay. Right. When I wrote these slides, there was a little more information on them. Let me just see if I can find that now. There we go. It's there. It's there. Yeah. If I can't get it to slideshow properly, I'll. No. Tell you what. How about I maximize this? Hello, go away. Try that one. Go away. Okay. Well, you can all read it anyway, can't you? Okay. Right. Well, we'll try with that then. Okay. So yes. The overview of the talk is I'm going to give a little bit of a retrospective on the releases we've had so far, an update on what we at Citrix are sort of looking at doing at the moment, and then the future directions that we might be thinking of going in. Okay, let's move to the next slide. Hello. I think I've crashed OpenOffice actually. Is it doing anything? Hang on. There we go. That's a bit better. Page down. There we go. That's a bit better. Right. Okay. So we've had 2 releases so far. We released 0.1.0 back, I think, in November last year, 0.1.1 in January. We've had a lot of positive feedback from these 2 releases. People are using it, people are modifying it, and people are building upon it. So that's really good. We've had patches come back from the community. We've even had patches to the OCaml stuff, which I think some people were surprised at. So I'd like to just take this opportunity to say OCaml is a really great language. You should really have a go at it. We didn't choose OCaml as some sort of barrier to entry. It's really nice, and you shouldn't let it put you off having a look in the internals of Zappy. Okay. So it's been a while, though, since we've had a release. And this is because we wanted to move to a sort of 2-branch release process. So what we want to do is have stable and unstable releases running concurrently. So the stable branch will be a well-tested and thoroughly reliable branch. We'll probably sort of we'll update that with bug fixes and things like that, and we'll do a sort of major changeover about once or twice a year, probably. And then the unstable one will release much more regularly, probably maybe even nightly builds, something like that. But that would be once we get the build process and the release process a little more automated. At the moment, our release process is invoking Dave, and he goes and does an awful lot of stuff for one day, and it gets released. So the intention is to make the next release of XCP the first in the stable branch. and this will be suitable for production use. Future versions of XenServer will be then based upon this, this stable branch of XCP. So as part of the release process, XCP goes through many machine years of quite intensive testing. So all of this will go to ensuring that XCP is really actually absolutely rock solid release. Okay, so of course the repositories that we have are all public. So theoretically anyone can actually go ahead and build their own release of XCP. Although we are aware that the build process is less than ideal at the moment. It's a bit hard. But I'll touch on that a bit in the next section. Okay, so what are we currently working on? So all of the development of Zappy now takes place on the public Xen API list. So those of you who are subscribed will know that the majority of the work that's been going on recently has been bug fixing. Hopefully that's good news for everyone. But we're now getting to the end of that phase. And in the next few months, you can expect to see a flurry of RFCs coming in on the list. And we'd really like to see feedback from everyone here, or anyone with an interest from the community about these. I can give everyone as kind of a sneak preview now of what's upcoming. So first of all, BlockTap 2. So this is part of Xen 4, but we've also got a port that runs on Xen 3.4.2. The current VHD backends that we have, so BlockTap is used for our VHD-based backends, which allow you to do thin provisioning and fast clone and things like that. The problem with those as they currently stand is that they are kind of partially implemented in the SM backend and partially implemented in Zappy. And this is because they rely on Zappy to manage the BlockTap disks, the tap disks. So what happens is that you call the storage backend, it returns you a path to a VHD, and then Zappy will go ahead and make the tap disk. So Zappy is responsible really for the life cycle of these tap disks. Unfortunately, some of these operations, the VHD operations like fast clone or a coalesce operation, they actually require the cooperation of the tap disks. So at the moment, it's not possible for the SM backend itself to be asked to clone and then do the operation entirely itself. It has to call back to Zappy, ask it to do a bunch of stuff, and then Zappy calls back. And that causes all sorts of horrible locking problems. So BlockTap 2 will fix this because it has a slightly different architecture. So what happens with BlockTap 2 is that you ask it to look at a VHD, and it returns you a real block device in DOM0, and then you can run block back on top of that. This can then be returned to Zappy, and Zappy doesn't need to know that it was actually a VHD, and we can drop all of that code from within Zappy, and that will be a much nicer architecture. And once we've got the management of the tap disk into the backend, that then opens the doors to some of the more interesting new features that TapDisk 2 can implement. So you can do things like, maybe we could have things like encrypted disks or on-the-fly compression or sort of new features like that, maybe non-local access to VHDs, sharing of VHDs between hosts. That will all be made possible with the switch to BlockTap 2. So the first user of this will be what we call VHDD. And this is an experimental sort of tech development project that I've been working on for a while. It's a replacement for the VHD-based storage backends. And it runs as a daemon, unlike the conventional storage backends, which are sort of little Python executables. So when Zappy wants to attach a VDI, currently it calls out to a Python program, sends a little XML RPC request on the command line. The Python program loads up, loads in a bunch of libraries, does the thing, and then shuts down again. So the VHDD will be a persistent daemon, sit there and will respond to the same SM API requests. Okay, so currently the Python backends, they take this XML RPC request. What we're doing, instead of passing that on the command line, is that we'll pass that through a Unix domain socket. And this will, we'll get the response back from the other end of the socket. And so more or less, well, there's very little change in Zappy itself. And so the interface is more or less the same. There's one or two changes, so in probe, that might require a bit of a discussion on the list, but that will be coming. We'll send out a message about that soon. Now, the advantages of this storage daemon is that you get a quicker response, first of all. But you can also, more importantly, do a caching of metadata. So one of our storage backends that we use for shared access to a block device is called LVHD, or LVHD over iSCSI. And currently the way this works is that whenever you want to attach disk, you spin up this Python program. It has to load in all the VHD metadata. It then decides which logical volumes to activate and which to deactivate, and then it shuts down and forgets all that information. And so this is one of the big advantages of a storage daemon. It can actually cache all this information, and things can be much quicker. This is actually quite important for larger scale, sort of maybe some sort of cloud, because as it turns out that as you get a large number of logical volumes, LVM actually takes a really long time, a surprisingly long time to read the metadata, maybe up to sort of 10 seconds for a few thousand disks. So we've also, with this, we have the ability to expose back-end specific API calls. An example of this would be to get the block allocation table from a VHD. So this tells you which blocks are allocated on as the name would suggest, which blocks are allocated in that particular VHD. And so you can tell the sort of sparseness map. That means you can do more efficient export or import of that disk, things like that. And then we've got the ability for this, because this daemon doesn't really need Zappy to run it. It can actually operate in the absence of Zappy, and other tool stacks, whatever they may be, can actually use it too. Okay. Now, at a sort of slightly earlier stage of development is a project to look at a more intelligent distribution of VHDs. So this is to allow more efficient transferring of virtual machines between pools. So say, for example, you've got a sysadmin who's got a virtual machine that they've set up in their own pool. They install a bunch of stuff on it, and then they want to transfer it to all of the other pools in their cloud. At the moment, you have to export that. You take this very large export and you import it sequentially to each of the pools in your your cloud. If the administrator then wants to change it in a very small way, maybe wants to install something more, or apply a patch or something like that, the only way currently to distribute this again is to re-export it and then re-import it to all of your pools again, which is very inefficient. So it would be much more efficient if we only transferred the difference between the two VMs. So that's what we can do to implement that, is to require the administrator to hit snapshot whenever he wants to deploy. That will create a new VHD in the disk chain, and that VHD will contain the difference between the last image and this current image. And then we only need to transfer that small VHD there. So this would be much more efficient for distribution of VMs between pools. Okay. Now, as I said before, building Zappy is not a terribly easy process at the moment. I don't know if anyone's actually tried it. I have, and it's horrific. Now, Unfortunately, the build infrastructure that we have internally in Zen Server Engineering in Citrix, which we use to build this thing, is not really something that we can release very easily. It's far too dependent on NIS users and various mount points and things like that, so it's not really suitable for use externally. Now, what I sent out, I sent out a script to the list a month or two ago, and that script was, you ran it in a CentOS, a 32-bit CentOS environment. And that script ran through the process of cloning the repositories, going through and building the thing. So that was used to make an individual Zappy executable. The short-term plan is to produce a few more of these scripts, or maybe make the one I sent out a bit bigger, so that it's much easier to rebuild the individual components of XCP. So, for example, rebuilding QEMU or rebuilding Zappy or Zen itself. And then that will at least enable people to make changes and deploy those the new binaries on their XCP setups. In the longer term, we'd really like something that was able to rebuild the complete ISO, so that people can build something on top of XCP and be able to distribute that and have people just install it as easily as they can install XCP today. If anyone is actually battling with build issues, please come and see me, and I'll be interested to see what things people are trying to build and what things they're trying to change, and we can maybe prioritize those when we figure out a better way to do it. So, RBAC. RBAC is role-based access control. And this is present in XCP in both 0.1.0 and 0.1.1. And what we're thinking about doing is improving what we've currently got so it's more suitable for a cloud distribution. So currently what we have is that we restrict an entire API call. So, for example, one person might have the permission to view a VM's console but not power cycle it. Another one might have permission to power cycle but not to provision new VMs. So it's kind of a broad swathe of operations that people are allowed to do or not. In the next version, what we're aiming to do is to restrict the ability to do operations to a particular subset of objects. So, for example, you might have a subset of VMs that are visible to one person but not to another. And this will move us towards the sort of self-service idea of software as an infrastructure as a service, where you give someone the permission to manage their few VMs and whatnot, sort of independently of the sysadmin of the cloud. This again will move towards the goal of having multi-tenancy in our XCP clouds. Once again, we'll be sending out RFCs about this stuff to the list fairly soon. And so if you do have any comments on that, or you want to make any suggestions, we're really keen to hear from you. Okay. Next up, the version of Zen that's currently in XCP. So today we're on 3.4.2 with quite a few patches. Now maintaining these patches is somewhat of a headache, and it's not ideal because XCP is running on a different thing to sort of the more usual open source Zen. And so what we'd like to do is move towards having maybe move towards Zen 4 and then Zen Unstable as well. So hopefully this will work in everyone's favor because the sorts of patches that we have are things like making error reporting more easy and diagnosing sort of error states, things like that. So that will actually be useful both ways to both XCP users and Zen users. So Vincent Hanquez is leading this work, so you can email him if you want to know more about that. Now, on a related note, libzenlite. So Stefano will be talking some more about this, and Ian mentioned this earlier. Libzenlite is a small C library that does very low-level operations to Zen. So it does things like start up a domain or shut it down, things like that. It's a very it's very low level. So this will be replacing what we currently have in XCP, in Zappy, which is a layer called XenOps. XenOps is a camel library that does much the same thing. It does the very low-level manipulation of Zen, does the hypercalls, the Zen store writes and reads. XenOps is shared between XCP, Zen Server, and Zen Client in various slightly different configurations, but not in ZenD. And so moving towards libzenlite will be really useful because everyone will be on a common underlying layer. So this will be will help with moving towards different versions of Zen too. Now it seems likely at this point that we'll have some sort of process separation doing this. So we'll have a process that links to the libzenlite and then the main Zappy process. And we'll probably do this because up to now we've really tried to minimize the number of C libraries that we link into Zappy. This has been quite a good win in terms of stability. So the last seg fault that was observed in a camel program that we thought might be due to a camel, it actually turned out somewhat bizarrely to be a bug in the North Bridge, I think. So it really is quite stable, and a seg fault is unusual to see. So this will probably be a gradual process of replacing the XenOps layer with Zenlite. We'll do it sort of piece by piece. So at some point it will be a bit of a hybrid situation. But then we will eventually stabilize on having purely libzenlite in there. Once again, when we've got a concrete proposal for this, how we're going to go about doing this change, we'll discuss it on the list. And please do send your comments in. Google Summer of Code. So we've got 3 projects accepted to work on XCP this year. So the web interface, this is DevWeb. I don't know if anyone's used that. Has anyone used DevWeb at all? Nope, one at least. That's good. So he will be working on that. So currently, DevWeb it's a very, as the name would suggest, it's a very developer-oriented web interface, and really more or less is a database viewer and the ability to invoke certain limited subset of the API calls. What we'll be asking him to do is to implement it implement the new functionality in terms of a library, really, because DevWeb is not really a sort of user-facing web app. And so if he does it in a library, then we can use that to make other more user-focused web clients later on. DRBD integration. So Sergio Charpinel, I think, will be doing this, being mentored by Dave Scott. What the idea here is to get a storage backend that integrates with DRBD to do replication of blocks between pools. Okay, so when you do a write to a block on this pool over here, that block of data will get transmitted over to another pool and be replicated over on that side. The reason this would be useful is particularly in the case of disaster recovery. So you've got 2 pools, your primary pool and your sort of backup pool, and you'll have your blocks being mirrored from your primary pool to your backup pool. You'll also mirror the VM metadata using the metadata import-export in Zappy. And if a disaster happens to this primary pool, it bursts into flames or something, then you can always restart your VMs on the other host over there. So that will be really useful. And also, once we get Remus going, we could do some really more interesting things once we got that in there. But we haven't quite got a plan for that yet. The third one is memory hot plug. So Daniel Kuiper will be working on this, and this is an alternative to memory ballooning. I'm not entirely sure the details of this. I think Jeremy is going to be mentoring him, so probably Jeremy is the person to ask. Lastly, I want to mention the kernel. So we're currently based on 2627. Now, most distributions are moving towards 2632, and it seems likely that this is a good way to go. So the version of the kernel, 2632, has PVOps support, but it's not clear yet. We'll have to do some testing and whatnot to figure out whether we actually go for a full PVOps DOM0 straight away, or whether we go for the Novell sponsored, Novell sorted out a kernel of where they forward ported the sort of normal old style Zen support into the kernel. So Ian Campbell is the person to ask about that. Yeah, if you want to know more about that, please email him or ask on the list. So where are we heading now? Well, I guess that's to a large extent up to you guys. So we'd like to know which directions you want us to move into. We're very keen for contributions from everyone. Yeah, the cloud is in its infancy at the moment, so we're in quite a good position to influence which way it's going to go. So please feel free to join in, dive in, join the list. The list for Zappy is zenapi@lists.zensource.com. If you want to look at the sort of documentation, then that's this Cloud Zen page there. Otherwise, all the source code is on zenbits.zen.org. Feel free to browse through. Yes, don't get put off by the OCaml. It is nice, honest. Right, okay. Yeah, thank you very much. That's the end of that.
So, Marco, why don't you come up to set up? So does anyone have any questions? We can maybe do one or two while Marco is setting up. No questions? Okay, go ahead. Oh, I got him. Okay. Passy has a question. There's a surprise.
Can everyone hear me?
Yeah, go ahead. Use the mic.
Okay. One question about like the public APIs. Do you have any plans to like implement or support some like public cloud APIs?
Which APIs, sorry?
Public cloud APIs.
Oh, you mean libvirt and things like that, or what?
Yeah, or like, well, the bad word, vCloud or something like that.
So we don't have any concrete plans at the moment, but I'm sure if someone wanted to do that, we'd be more than happy to take that. Yeah. So, but no plans to do that at the moment.
Okay.
Not in as far as I'm aware, though. That may change in the next few minutes, maybe. Anyone else? Yep, at the back.
I have a question on upgrades. What are the plans for doing upgrades other than just reinstalling XCP?
It would be nice to be able to do, say, a Yum upgrade, a sort of Yum distribution upgrade type thing. That would be nice, but it's quite a lot of work, and I'm not sure we have the resources to do that ourselves at the moment. What we have got, there is a project in the works that might be of use there, which is we've got a VM that boots up and acts as a PXE target. So the idea would be you boot up this upgrade VM, and then you reboot your hosts, and they will connect to the, you can do it one at a time. They'll connect to this PXE target and boot off the new image and upgrade themselves. So this might be a nicer way to do it than sort of automate the process, but it will still go through the effectively a reinstall step. Yeah.
Will you be staying with CentOS as the base distribution?
As far as I'm aware, that's the current plan.
I've heard rumors about LusterFS as a storage for Bootstrap.
Yeah, so I've also heard rumours. I've not seen anything concrete. As far as I'm aware, Gluster it's presents itself as a file system. We have some storage backends that use networked file systems. So we have an NFS file system. So if it's as simple as changing the mount command, that would be we could sort of support it in that sense. I don't know whether it supports, I don't know that much about it, to be honest, so if it supports any more advanced things than that, it would require a bit more work. But the storage backends, the storage plugins, they're relatively straightforward, most of them. The complex ones, the VHD ones, and that's because half of the code is in Zapier, as I said before. It's otherwise they are fairly straightforward, and you can look at the source code and have a look. And I think we've got some documentation on the storage interface, but not a terribly detailed one yet. But that should be coming out fairly soon, actually. We're going to rev that documentation soon.